Good morning, class. Welcome to our new lesson. And for today's lesson, we're going to discuss Metamorphism in Rocks. This is your teacher Aimee and Cheta, bringing you this lesson to the comfort of your home. So, first we're going to define what is metamorphism or what is metamorphosis. So when we say metamorphosis, it is a change of physical form, structure of a substance, specifically by supernatural means, and the metamorphosis of humans into animals, like for example. So it is also a striking alteration in the appearance, character, or circumstances. Like for example, the company has gone through a series of metamorphoses. So, metamorphism is a change in the constitution of rock by pressure, heat, and water that results in a more compact and more highly crystalline condition. So, there are different kinds of metamorphism. Number one is the thermal metamorphism, which is known as the contact metamorphism. When heat is dominant in this magma, it is a igneous forming rocks. It is a dominant factor to form a metamorphism. So it is due to the increase in the depth and intrusion of magma. So when that happens, thermal metamorphism will be formed or happened. So we have here some example. A contact metamorphic rock made of interlayered calcite and serpentine from the Precambrian age. So the second one is the dynamothermal metamorphism. It is also called regional metamorphism. It is a combination of heat and pressure, more or less complete recrystallization with new structures. So if a certain pressure is exerted in this side and also in this side, so what will happen? The direction of the slate cleavage will be upward. So you can see the different layers is bended and it will form like this. So another example is Mississippian marble in Big Cottonwood Canyon, which is located in the Wasatch Mountains in Utah. As you can see, the formation of rocks is like this one. Okay, rocks are being subjected to high pressures and temperatures, so they form like this, some layered. So we have classification based on the texture and structures of minerals. Number one is foliated, or what we call structure. Parallel structure, rather. This is rocks that contain mica and ferromagnesium minerals. Minerals flattened and arranged in parallel layers. For example, the gneiss, the cyst, and the slate. The second one is then foliated, which is the massive structure. Rocks that contain quartz and feldspar, for example, the anthracite, talc cyst, these are non-foliated. The third one is the granular. Granulars are rocks comprising mostly of equidimensional grains, for example, the quartzite and the marble. So we have the important metamorphic rock. We have the gneiss. It looks like this. It is a typical folded strata in gneiss. Gneiss is a metamorphic rock formed at high temperature and pressures deep within Earth's crust. The high pressure produced the folds in the bending seen here. The lighter colored layers are formed by quartz and feldspar, and the muscovite, biotite, and hornblende. So this is the lighter color, are commonly abundant in the darker bands. Another example is the classified as gneiss also was identified as having come from Wyoming from the North Laramie Mountains. One part of it was associated with an age of 2.6 billion years and another part as 1.8 billion years. The second one is the cyst. It is an intermediate to high-grade foliated metamorphic rock. highly variable in appearance depending on the mineral content, which is a function of the precursor rock and specific temperature pressure conditions. Cysts typically have medium to large sized crystals, unlike the microcrystalline nature of slate and pyrite. So this is the examples of cysts. We have the muscovite cyst, the biotite, garnet, coalite, talc, and the graphite. Slate is the third one. Slate is a fine-grained foliated metamorphic rock that is created by the alteration of shale or mudstone by low-grade regional metamorphism. It is popular for a wide variety of uses such as roofing, flooring, and plugging because of its durability and attractive appearance. The fourth one is the quartzite. It is a hard, non-foliated metamorphic rock which was originally pure quartz sandstone. Sandstone is converted into quartzite through heating and pressure usually related to tectonic compression. The fifth one is the marble. It is a non-foliated crystalline rock composed of calcite and dolomite. And we have here the pre-existing rocks and their equivalent metamorphos. So we have here a conglomerate. A conglomerate is a sedimentary rock which will be converted into a metamorphic rock. Conglomerate will become now the genus. So from this, it will convert it to this. We have also here the basalt, which is an igneous rock. It will be metamorphosized and it will convert it into a cyst like this. From this into this. From sandstone, another is a sandstone, which is a sedimentary rock. It will be converted into quartzite, and a quartzite, which is a metamorphic rock, will also undergo some metamorphosis and it will be converted into quartz cyst. From shale, we have a slate, then from slate to pyrite, then pyrite to mica cyst. So this is the metamorphism of a rock. Another example is the iron ores. An iron ores will be metamorphosized and it will be converted into hematite. Okay? We have the gabbro, which is an igneous rock, will be converted into metamorphic rock, which is a genus which is a metamorphic rock, and will be converted into coalite cyst. Another example is a coal. So if you want to get a graphite from a coal, it will be, you have to subject it to high pressure and temperature and you can form a graphite. So we have metamorphic rock textures. There are 5 basic metamorphic textures with typical rock types. We have the basic rock texture, the metamorphic rocks, and the name of foliation. We have number 1, slaty. Slaty is slate and pyrite.